Alright, welcome to this tutorial class in physics. Today we'll be talking about electric force between 2 point charges. Basically, we'll be looking at the Coulomb's law of electrostatic force. Generally, the basic law of electric charges states that like charges repel and unlike charges attract. So based on this, Coulomb's law of electrostatic force came into being. So the law states that the electrostatic force of attraction or repulsion, call it Fc, between 2 point charges is directly proportional to the product of the charges and inversely proportional to the square of their distance apart. So this is what this law is simply talking about. So I'm going to split this law into two forms and then combine them together to form a singular mathematical expression. So here we have mathematically, we say force of attraction or repulsion Fc varies proportionally to the product of the charges, call it Q1 and Q2. So this is the first expression that we have. So we have this. This same force of attraction or repulsion is also inversely proportional to the square of their distance apart. So we have 1 over r squared. This becomes our equation 2. So if you combine these two equations together, combining equation 1 and 2, you are likely supposed to have Fc proportional to Q1, Q2 divided by r squared. So we lift this sign of proportionality from here. We have Fc to be equal to K Q1 Q2 divided by r squared. So this is what we have. But we can further simplify this more, where K is equal to 9.0 times 10 raised to the power of 9 Newton meter squared per Coulomb squared. And it's still the same thing as 1 divided by 4 pi permittivity of free space. Permittivity of free space. So if you combine these together, you are likely supposed to have from here you are supposed to have but epsilon naught is the same thing as permittivity of free space, which is equal to 8.85 times 10 raised to the power of minus 12 farad per meter. So from that expression, from this expression, we can simply put that the force of attraction or repulsion, Fc is equal to K Q1 Q2 divided by r squared, and is the same thing as 1 over 4 pi permittivity of free space multiplied by Q1 Q2 divided by r squared. So if you further put this together, you have Q1 Q2 divided by 4 pi permittivity of free space multiplied by r squared. And this becomes another formula for it. Now, defining all the parameters where Fc is equal to force of attraction, Q1, Q2 are charges, R is equal to distance between the two charges. Recall that we have K to be constant of proportionality, constant of proportionality, which is the same thing as 9 times 10 raised to the power of 9 Newton meter squared a Coulomb square. I think the last parameter that we have here is the epsilon naught, which is this permittivity of free space 8.85 times 10 raised to the power of minus 12 F per meter. So this is basically what we have from that aspect. So if you go back to this slide again, the first slide, you will possibly see this. So uh, in summary, we can simply put uh, in summary, we can say that sorry, we can say that FC is proportional uh, to Q1, Q2, which is equation 1. FC is proportional to 1 over R squared, which is equation 2. FC is proportional to K, Q1, Q2 over R squared, which is our equation 3. So, or we can simply say FC is equal to Q1, Q2 over 4 pi permittivity naught times R squared. So, these two are still the same thing that we are talking about. All right, so the second aspect we want to talk about is the electric field intensity, um, or the field strength, which is defined as the force experienced per unit charge. The force experienced per unit charge. So here we can simply say um, mathematically, mathematically here we have E, which is the electric field strength or the field intensity, which is equal to force experience per unit positive charge. So if we take this as our basic formula for the electric field strength or intensity, call it. Now let's try to bring in uh, from, let's call this okay, from Coulomb's law. From Coulomb's law, F is equal to K Q1 Q2 over R squared, so that E becomes K Q1 Q2 uh, over R squared, or divided by 1 Q. So if Q1 is equal to Q, automatically it means that E will be equal to K Q Q2 over R squared divided by Q, so that this will now cancel this. So if we have this way, automatically we are going to be having uh, E to be equal to, because note that here we are having note that here we are having K, then we have Q2 that is also remaining. So from here we have sorry, we have K Q2 that is remaining, divided by what? R squared. So here we can simply Therefore, E is equal to Q divided by R squared. So you can either have this or you have E to be equal to force over charge. Now, this can further be this, or E is equal to Q divided by 4 pi permittivity of free space multiplied by what? R squared. Since K is equal to 1 over 4 pi permittivity of free space. So this is what we have as regarding um, electric field strength or electric field intensity. Remember that the unit of measurement of this unit is Newton per coulomb. All right. So next thing we want to talk about here is the electric potential. The electric potential. Electric potential itself is a scalar quantity because it measures only the magnitude of the potential energy. It does not um, take cognizance of the direction. It's only the magnitude. So we say that the electric potential E, VE, at a point in an electric field is defined as the work done in taking a unit charge from infinity, to that point, and it is measured in volt. So here, what we are talking about here, we are saying this is VE is equal to work done over what? A unit charge. So let's simply make this uh, one of the equations. So if we have this as one of the equations, uh, but recall that work done is equal to force multiplied by what? Uh, Distance. So we are having work to be equal to force times distance. Put this one to the equation 2. So put 2 in 1. It implies that VE is equal to F times R divided by Q. This becomes our equation 3. So from here, let me add a new slide to this. So from here, we are likely going to be having something this way. Now recall from Coulomb's law. Recall that Fc is equal to KQ1 Q2 divided by R squared, which implies that VE is equal to, if we substitute this into equation 3, we are likely supposed to have KQ1 Q2 divided by R squared multiplied by R all divided by Q. So from here, if if Q1 is equal to Q, automatically we are going to be scrubbing this against this. One of these is going with one of these. So we are going to be left with VE to be equal to Q2 divided by R. This is possibly what we are going to be having, and this becomes our equation 4. So from here, from this point, we are saying that VE is equal to Q2 over R. Let Q2 be equal to Q, just a Q, so that we have VE to be equal to what? KQ divided by R, and this becomes the electric potential that we have, so that VE is equal to uh, work done over charge, or VE is equal to uh, KQ over R, or VE is equal to Q over 4 pi permittivity of free space multiplied by R. This is automatically what we have. In our next class, we are going to uh, prove that ER is equal to V. This is all we are going to do in our next class. Prove that ER is equal to V. Thank you so much for watching. In case you have any question to ask, uh, feel free to ask anytime. So before I round up, in summary, just to summarize the whole thing that we have done today, FC is equal to what? Q1, Q2 divided by R squared, and is equal to what? Q1, Q2 divided by 4 pi permittivity of free space multiplied by R squared. This is force of attraction or repulsion from Coulomb's law. The electric field intensity E is defined as force per unit charge. And is the same thing as KQ over R squared, and is the same thing as Q over 4 pi permittivity of free space multiplied by R squared. And we have electric field potential to be equal to force per unit positive charge, which is the same thing as KQ KQ over KQ over R. Yes, so we have KQ over R from there. KQ over R. KQ over R, and which is also the same thing as Q over 4 pi epsilon R. Now, it is good for you to note that from here, we also have K to be equal to 1 over 4 pi permittivity of free space. And this same K is the same thing as 9.0 times 10 raised to the power of 9 Newton meter squared, a Coulomb squared. And we also have epsilon naught to be equal to 8.85 times 10 raised to the power of minus 12 F slash N. So this is what we have so far in this class. Thank you so much for watching. We meet in our next class.